Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. I also want to welcome the students of 11th and 12th Science for especially Chemistry, Fundamental Concepts in Organic Chemistry. Now this is for class 11th and 12th because this is the fundamental concepts you will clear, and this is the part 1. The part 1, electron movement in organic chemistry. The question is, what are the type of electron movements and how the bonds are formed? What are the bonds present in organic compounds? Especially the bonds which are present in organic compounds are sigma and pi bond. Sigma and pi bonds. Sigma bond, that is simply strong bond, head on head overlapping, and pi bond sidewise overlapping. That is why sigma is very strong bond whereas pi is the weak bond. Now here the electron movement are two types. It may be a pair of electron moves or a single electron moves. That means electron may be single electron, or maybe pair of electron. Now see the movement like this, single electron or pair of electrons. So first point, you see the movement of electrons in organic reaction shown by chord notation. That means this is chord notation. Here it indicates that a pair of electron moves from here to here. Again see the movement of electrons in organic reaction, that is shown by chord notation. This is the chord notation having arrow. Here this is arrow, this is the tail. So this is head and this is the tail, and tail means here the electron moves and arrow means the electron comes to that point. Again second point, the movement of single electron. Now it is pair of electron, one pair electron, one arrow mark. Now here movement of single electron, that is shown by a single barbed fish hooks. Single, see here this one means it is just like fish hook structure, or you can say half head. This is if it is full head and this is the half head. Full head, half head, what is the difference? This is the half head, and if it goes like this, then this is the half head and this is the full head. Now it looks like fish hooks. It looks like a fish hooks, the movement of single electron shown by fish hooks, or you can say half headed arrow. This indicates the electron moves from here. This is from the part where electron starts to move, and here the electron drop here, or here it comes to the end point. Example, CH3Cl, this is a covalent bond, that is sigma bond, and here the one electron move this side, one electron move this side. So since it movement one electron, single electron, that is why it is represented by half-headed curved arrow. It is represented by half-headed curved arrow, or you can say fish hooks. And so this is the two type of movement of electron. One is pair of electron moves and second is single electron moves. The curved arrow starts from the point. Starts means from tail it starts. From the point when an electron pair is shifted, suppose from this area to move to this. That means here this point the electron starts to move and here it drops here, so the arrow mark like this. So the curved arrow starts from the point when an electron pair is shifted. Suppose from here the pair of electron want to shift, and it ends at a point, at a location, at a point, at a place to which the pair of electron may move. That means here its starting point, here it is ending point. Here it moves electron from this location to that location where there is an arrow mark. That means it is located that point where the electrons comes to here, come to that location. So the curve, now there are three types of movement of electrons. movement of electron means pair of electron. Now see, it is one example where you indicate this is a double bond, it is a single bond, and Y is a substrate or any molecule. Then what happened? Here see, since there is a double bond, what is mean? Mean one is sigma, other is pi. One is sigma, which is strong head-on-head overlapping bond, and other one is pi, that is side by side overlapping, that is weak bond. So here the weak bond will pi bond, and it moves, the electron moves, the pair of electron moves from this to this bond. Y is in middle, one side there is a single, that is sigma bond, and this side there is one sigma bond, and there is one also pi bond. So pi bond electron moves from here to here. So what is the result after moving the electron, pair of electron, that pi electrons? So here that electron, since it moves to here, it becomes double bond, and it is become to single bond because already electron moved to that side. So here what type of movement of electron? From pi bond to adjacent bond, from pi bond to, this is called adjacent bond, this is called adjacent atom. So the electron moves to adjacent position, adjacent bond position. Now second case, in second case what happened? Now you know this is the same case, but here the electron only moves to adjacent atom. Which one is adjacent atom? Now Y in the middle, and this side is one single bond, that is sigma bond, and that side, here this side one is pi, another is sigma. So what happens? The pair of electron moves to adjacent atom Y. So that is why the result is it becomes to single bond, and Y occupies a pair of electron, and this as it is single bond. So what is the type of movement? The from pi bond to adjacent atom, that is Y. In third case, you see what happened here. Here Y there is a pair of electron, and this left side there are two bonds, one is sigma, one is pi, and right side singly one bond, that is sigma bond. Now what happens, since there are already two bonds, so the electrons only chance to move this adjacent bond, that is single bond. So here the pair of electron moves to this one. So what happened? Next result, since it moves to this bond, that is where it occupies double bond, and there is the electron pair moves. So nothing here, no pair of electron present now. Here this is single bond, and this side double bond. So here what happens, since the electron moves, so it is will again changes to single bond. And what happens here? Sorry, it is should be single bond, not, because single bond Y there is a pair of electron, that side single bond, so it is now okay. So the movement of electron like this, so it occupies, it changes to double bond, one is sigma, other one is pi. So how can you write what type of this movement? From atom in Y, atom Y to adjacent bond position, that means from atom to adjacent bond. Now there are three types, again see, there are three types of movement of electron: from bond to adjacent bond, from bond to adjacent atom, from electron pair from atom to adjacent bond. So again see the electron movements here, there are two types of notation. One is arrow, curved arrow notation, that when a pair of electron moves, and if single electron moves, that is by half-headed arrow, curved arrow, or you can say fish hooks, and that is the structure like this. And now here, if CH3Cl, and this side half-headed arrow, this side half-headed arrow, movement of electron like this. So this is the result, CH3 dot and Cl dot. And the curve arrow means what? The tail, that means indicates it movement of electron starts from tail and ends in arrow, curved arrow. And this is the type of electron movement in organic chemistry. In second part we will see the type of fission, how cleavage of the bond or fission, bond fission we will discuss. So I hope you clear this movement of electron in organic chemistry. Hope you will subscribe, share and like my channel, BL the short and sweet in chemistry. Thanks.